Hello everyone, it is April 21st, 2021, time's about 12:10 CDT, it's 41 degrees Fahrenheit out, and it is Geo-Rant time number 144, and I'm going to talk about Archean tectonics. But before I get into that, I just want to say, first of all, there was snow on the ground this morning, and for those of you that know me know that tomorrow will be the 1-year anniversary of when I put my cat Ezra down, and he was my best friend for 13 years, even though he was 15 or 16, because I got him as an adult cat. And I do miss him, and I still miss him. And anyway, I digress. He was a good boy, bestest boy. Anyway, okay, plate tectonics. In the 1960s and 70s, we developed this theory of plate tectonics, and it answered a lot of questions in geology about how things came to be, like orogenic events, things like that. And it gained acceptance like that, and that doesn't usually happen. It explains so much that it just became universally accepted. By the 70s, we had this concept down. During the 80s, we tried to figure out just exactly what the motions are. We started taking measurements, things like that, and solidifying the concept of plate tectonics. So by the 90s, we had a very good working model that's still in use today and has not changed much at all. The only thing that has changed is the mechanisms that drive these plates, but this is a talk for another time. I shouldn't say change, I should say order of priority, which is the dominant over whatever, because it's probably all three, if not more. Anyway, I digress. But the point is, in order to have plate tectonics, you need to have a rigid lithosphere moving about the globe in plates and being recycled into the mantle to some degree. And that rigid lithosphere, which is the very top of the mantle, and the crust, doesn't matter if it's oceanic or continental, that is involved in that plate tectonics. All right, it's just the oceanic crust gets recycled, or the oceanic lithosphere gets recycled. The continental lithosphere generally does not. All right, so just because a planet might have some sort of crustal recycling doesn't mean plate tectonics is in operation. The definition is very specific on what constitutes plate tectonics, and Earth is the only planet known to have it. There's other forms planets can lose their internal heat, and there's something called lid tectonics and things like that, talks for other times. But anyway, plate tectonics answered so much, but there's a problem. When people tried to extrapolate it into the Archean, it failed. Well, why? Because something was going on from the formation of the Earth, 4.5 billion with a B years ago, to the end of the Archean, 2.5 billion with a B years ago, with a transitional period to plate tectonics from around 3.2 to 2.5 billion years ago. And plate tectonics has likely changed from when it originally, started at the beginning of the Proterozoic, that 2.5 billion years ago. Something else was in operation during the Hadean and Archean, and we aren't sure what. Some people have tried to push plate tectonics back to the beginning of the Earth, but it's usually geochemists who don't understand plate motions or geophysics or very well and stuff like that. And like I said, it's usually the argument that, well, we see evidence of crustal recycling, therefore plate tectonics. And I've just explained how that's an erroneous extrapolation, especially in an isolated area. Now, there is evidence of something called Wilson cycles back to the beginning of the Proterozoic, that 2.5 billion years ago. Sorry, a little congested. And we have strong evidence of things that would give evidence of modern plate tectonics or something like it in operation. We have continental shelf deposits like the Hadean supergroup. We have the development of intercratonic basins like the Belt supergroup up in Montana and Purcell in Canada. That's a little younger, but it's still Proterozoic. And we have things like ophelites and stuff like that up on the continent. We have evidence of Wilson cycles, the opening of an ocean and the closing of it, which is something we don't have in the Archean and Hadean, with one possible exception in southwestern Ontario that's about 3.2 billion years old. Talk for another time as well. And anyway, before I digress, why do we think plate tectonics wasn't in operation and what could have been? Well, there's several factors. Paleomagnetic data is the first. And I've been reading this book from the 1980s called Precambrian Plate Tectonics. I think it was 1981. And I do this on occasion to see what people were thinking back then and how we've developed our theories, because the history of this stuff is important too. But there's a lot of still good information in it. Just because something's 30, 40, 100 years old doesn't mean it's worthless, all right? But we can get good paleomagnetic data back to the beginning of the Proterozoic, that 2.5 billion with a B years ago. What is that? Well, that means we can reconstruct positions of the continents. Well, how can we do that? Most people, when they think paleomagnetism and the data we get, they think about us pulling it from the modern ocean crust or from the ocean crust around the globe. But that crust was not around 2.5 billion years ago. So how can we know where the continents are? Well, there's dike swarms associated with orogenies and things like that. And as long as they're undeformed in the continents, we can date those. And we can do this with pretty good accuracy, very good actually, back to Rodinia about 1.1 billion years ago. So since at least then we've had really good plate tectonics in operation. But we can also do it up to about 2.5 billion years ago. But before that, we can't really do it. This method sort of breaks down, and that could mean a couple of things. It could mean plate tectonics wasn't in operation. It could mean we didn't have a dipole magnetic field. It could mean that the magnetic field was not very stable, and it could be a combination of all these. But this is just one line of evidence that I don't think it's a coincidence that this is difficult into the Archean. But there's other things too. There's TTGs, tonalite, troglodyte. I don't remember how it's pronounced. But you can Google TTG and it comes right up. I can never pronounce that word. But it's basically, you know, in the Hadean, well, we don't really have any for sure Hadean rocks, you know, that are that are actual continental crust. But we do have old Archean up to about 3.8 for sure billion with a B years ago. And during the Archean, we see these TTGs. These are not true granites. They're granitic rocks, but they're on that plagioclase-rich side of the QAPF diagram. And we don't see those today. I mean, there are some. We do get them in island arc environments. But after 2.5 billion years ago, actually about 3.2 billion years ago, they all but disappear, okay? So that's another sign that maybe something different was going on. We have, and even for plate tectonic, when plate tectonics was in operation in the Proterozoic, we get much slower plate velocities, which seems counterintuitive if we had a warmer lithosphere. But we get that as well, according to this, about half as fast as the plates move today. But the plates do vary from, you know, location to location, so that could just be a location thing. And you know, lack of a Hadean crust. We don't have any crust older than 4.5 billion years ago. And before you say the Jack Hill zircons, I just want to say that isn't much. Those are zircons detrital that eroded from somewhere else in much younger conglomeratic rock. And we argue about the age of that, but at best, that's Neo-Archean. So it's a lot younger than that. So the source rock is gone. We don't know where they came from. So this is a big problem. And so we're pretty confident that plate tectonics was not in operation during the Archean and Hadean. So what was? We're still trying to figure that out. And this is one of those areas in geology. People have many ideas, and a lot of them are good, and a lot of them make sense. But with a lack of a rock record, it gets really difficult to try to figure that out. And we do know that during the Archean, we had continental land masses to some degree, and we had life, and we had oceans, and we may have had oceans since the Hadean. So what was in operation? We don't know. And until we find some actual cratonic areas that are actually Hadean and we can start getting better dates, we need to focus, in my opinion, what geoscientists should focus on in the next 10 to 20 years is paleomagnetic data, is trying to date these very old rocks so we can lock down an age and try to assemble a very good Precambrian, well, pre-Archean or pre-Paleoproterozoic model of how the continents moved. Anyway, I think that's it. I think I'm done. This is over 10 minutes. If you have any questions or comments, please leave them below, and I hope you learned something.